Welcome to Extra Science Academy, and in this video I'll be showing you guys on how to answer questions based on vertical projectile motion. Right, so now as you can see we got question 3 over here, right? And it says that the sketch graph below shows the motion of the ball that is thrown vertically upwards from a balcony of a building. The ball takes 0.6 to reach its highest point, after which it falls downwards, right, past the balcony to the ground. Ignore the effects of air friction, right? So now as you can see we got this graph, and this type of graph we know it's called the position time graph, right? We know it's called that, right? Because as you can see on our y-axis we got our position, and we know that position is distance, right? Is the height in another scenario, right? Is height. And then on our x-axis, as you can see, we got time, and time is measured in what? In seconds, right? So now over here you can see our motion starts right here, right? Our motion starts over here, and over here we were supposed to be having v initial, right? V initial, right? And then the height above the ground, is 10 meters, right? Because the ball was thrown 10 meters above the ground. So now we're going to be saying delta y. So why are we using delta y? Because this is a vertical motion. So over here delta y is for vertical motion, and delta x is for horizontal motion. So always make sure you're using the correct formula, right? Remember to use the correct formula. So in this scenario we'll be using delta y, right? For VPM always use delta y because it's vertical motion, right? So now over here, now let's analyze this. Let's analyze the information. That's the first thing that you want to do. Delta y is equal to 10 meters, right? And now this 0.6, this time over here 0.6, this is the maximum time. Are you seeing that, right? So over here at this point over here we know v final at the maximum height, we know it's what? 0 meters per second, right? The velocity at the maximum height is always 0 meters per second. And also we know time max, and t max, the maximum time at the maximum height, will be 0.6 seconds, which it was given, right? So which other information do we have? Okay, that's it. Okay, now let's start answering, right? So now it says that 3.1 says how high is the balcony above the ground, right? So for 3.1, as you can see, is only for one mark. You could have just said 10 meters, right? 3.2, which says write down the numerical value of time t. So as you can see, time t is right here, right? Over here, right? So let's use a different color. So now over here, right, you can see this over here is a semicircle, right? Went all the way until here. It's a semicircle, right? So now as you can see, the semicircle, and this 0.6 this time is being divided in half. So from here to here is 0.6, because we know from here, from the start, is just what? 0. So from here to here it's 0.6, and then from here to here, which is t, what will that be, right? So since this is the halfway, right, we're just going to times this by 2, right? So for this time over here we are going to say 0.6 times it by 2, which will be equal to, you can take out your calculator, right, put that on the side. So 0.6 times it by 2, that will give us 1.2 seconds. So therefore t, the numerical value is 1.2. They just want the numerical value, right? So you're just gonna say 1.2, right? So now for 3.3 they want you to define projectile motion. So I'm pretty sure you guys know all these definitions of projectile motion, right? So we can put that quickly for us right here. And we know an object which only force acting is the force of gravity. That's our projectile motion, right? So there we go, we have it over there. And now 3.4 says that calculate the initial velocity of the ball, right? So calculate the initial velocity of the ball. So they want v initial. So over here you have to check where you have enough information. That's the first thing that you want to do. You need to check where you have enough information. So let's have a look. We know the height above the ground, right? We know above the height above the ground, which we know it's delta y, which is 10 meters. We're looking for v initial, right? We have v final at the maximum height, which is 0 meters per second, and we also know time at the maximum height, which is 0,6 meters per second, and acceleration due to gravity, which we know it's 9,8 meters per second squared, right? So the other important thing that you need to do is choose direction, right? So for me, I prefer taking downwards as negative, right? I prefer taking everything downwards to be what? Negative. So I take downwards to be negative. That means my A will be negative 9,8 meters per second. Or you could have taken upwards, right? But just to avoid confusion, I just take downwards to be negative 9,8 because I'm comfortable with this one, right? So now let's have a look with our formulas, right? We're looking for V initial. So we got V initial, we got V max on this, the first formula. We know what A, and we know the time. So we can use the first formula, right? So now we're just going to say Vf is equal to V initial plus A delta T, right? So just because we had delta y is equal to 10 meters, that doesn't mean that we have to use it, right? You can check any other formula, right? So now Vf we know is 0 is equal to V initial plus A, which will be negative 9,8, and my time at the maximum height will be 0,6. So now 0 is equal to V initial minus, right? Let's take that down. Let's put this on the side and let's punch this in. So now we have negative 9,8 times 0,6, and that is going to give us negative 5,88, right? And then what do? We transpose this side, and it's going to become positive. So V initial is equal to 5,88 meters per second, right? And then you will have to include direction. So you're going to say 5,88 meters per second upwards, because you see upwards came out to be positive, right? Upwards, just like that, right? So that's how we answer now, right? So now let's have a look. So now they want you for 3.5. So now you're going to say calculate the maximum height above the ground reached by the ball, right? So they want to know the maximum height above the ground reached by the ball. So now they want, if they want the maximum height above the ground, so the keyword here was above the where is it, reached by the ball, right? Above the ground, there we go, right? So they want to know the height from here where it was 0,6, which is the ground, right, all the way to here, right? They want to know that because it says the maximum height. So where do you think we're going to get the maximum height? So the maximum height happens at the turning point of the graph. So the turning point happens here, right here, right? So they want to know that height. So we know this height already from the ground to the building, which is 10, right? Up to here, we know that's 10, right? So now we already given that. We know this is 10. So what we can do is find this height from here all the way to here. We can find that. We can find that height. We know V initial, we know V final, we know T max, and yeah, now we can find this height from here to here. Now let's have a look. Which formula can we use? So we have V initial, we have V initial, we have V max, V final, V max. We know the acceleration due to gravity, and we can be able to get our delta y. Right, so let's use that. So now you can just say V final squared is equal to V initial squared plus 2a delta y, right? So V final max, we know that it will be 0 squared, right, is equal to V initial, which is 5,88 squared plus 2a. A in this scenario is negative 9,8, right? And delta y. Are we saying that right? So now let's work out. So this now will be 0 is equal to, now let's take our calculator. So now we're gonna have open bracket 5,88 close bracket squared, and that is going to give us 34,5 minus, this will give us 9,8 times 2, 8 times 2, which will give us 19,6 delta y. So we can transpose this 19,6 this side, right? Transpose that, and then it'll become positive, right? So this will become 19,6 delta y is equal to 34,5744. So now you're going to divide this by 19,6, divide that by 19,6, so cancels out, so delta y, right, is equal to, now take your calculator, so now you're just going to say 34,5744 divided by 19,6, which will give you 1,764. 1,764, right, meters, right? So now this is the height. This 1,764 is the height from here above the building all the way to the maximum height. This part over here, we can use another, yeah, we can do that, right? So this is 1,764 meters, and then from here to here we know this is what, 10 meters. So now they want to know the maximum height above the ground. If they said the maximum height above the building, it would have been this answer, right? But it would have been this answer here, right? So now they said above the ground, so now we're just going to add this two. Now you're going to add that and that, right? So make sure we pay attention to the keyword. So now we're going to say therefore maximum height, you're just going to say 10 plus 1,764, which will be equal to I believe it will be 11,764 meters, and that will be our final answer. And that's it, right? So now let's have a look. So now they want 3.6, right? So 3.6, they said calculate the magnitude of the final velocity of the ball when it reaches the ground. So they want to know V final when it strikes the ground, right? Velocity of the ball. So they want to know the velocity over here. They want to know this velocity when it strikes the ground. So we know V initial, right? We know V initial. We're looking for V final, right? We do not know the time of flight. We don't know the entire time of flight. We can't use this t because this t stops right here, right? It stops at this point over here, right? So we can't use this t. We can't use this value. So it's pretty much we don't know the entire time of the flight. And the other information we have is this height over here, height of the building, right? Height of the building, we have that, right? So let's work it out. Let's work it out now. Let's look with what information can we use. So we need to avoid time, right? So let's try and avoid time. We can use again to Vf squared is equal to Vi squared plus 2a delta y. We can use that. So now we can say now Vf squared is equal to V initial squared plus 2a delta y. So V final squared is what we're looking for, right? Which is equal to V initial, which is 5,88, right? 88 squared plus 2, acceleration due to gravity will be negative 9,8, right? And your height now, your height won't just be 10, right? because now the motion here, now remember, it will be downwards, going downwards, right? So now the height will become what? Will become negative, right? Because the motion of the ball now is going downwards. The height will be negative 10, right? Just like that. Now, so now VF will be VF squared will be, now let's punch that in. Let's open that, 5,88 close bracket squared plus 2 open bracket negative 9,8 all over close bracket times negative 10 close bracket, right? And now final answer is 230 comma 5744 and then square root that. So V final, remember when you square root any answer, it's either positive or negative, so let's square root that. So once you square root that, it's going to give you 15 comma 18467, right? So now positive or negative, right? But now remember, the motion of the ball now is going downwards, right? So V final has to be negative. So V final will be now to be just be negative 15 comma 1847, and then you're gonna say V final is equal to 15 comma 1847 meters per second, then you indicate downwards, right? Indicate downwards, right? So this will be the final velocity of the ball when it strikes the ground, to be 15,1847 meters per second. So now they want you to say to write, they say for 3.7, they say draw the velocity versus time graph. So we know the velocity time graph is a straight line, right? For the motion of the ball, indicate the following on your graph. So indicate the initial velocity, final velocity, and time taken to reach the maximum height. So these are the key points. This is what you need to indicate, nothing else. So now for 3.7, we can put it down here, and now we can put down our straight line, vertical straight line. We can go like that, right? So we can put it down like that, and you don't need scale over here, right? You pretty much don't need a scale. So now you can put this, you can divide this halfway, like over here. Put it like that. Yeah, so it goes on like that. So now over here, we know on your y-axis you're gonna have velocity, and over here you're gonna have what? Time. So now V initial, remember this side is the positive side, remember this is the positive side, and down here is the negative side. So now remember time, and down here, right here, is 0, right? So now if this side is the positive one, positive, now the V initial, remember our V initial, we calculated, and V initial was 5,88. We calculated right here, we had 5,88. So now we can say 5,88 is somewhere here, right? We can say it's somewhere there, right? We can say that. And then they want to indicate the final velocity. So now the final velocity, they want it to be negative 15, so negative is this side. So if this is 5, this is going to be like 5, 10, 15. So it will be somewhere here, right? Right here, right? So you can put a line over there, dot I mean, right? And then they want you to indicate the time taken to reach the maximum height. So maximum height time, we know we read it was 0,6, the maximum height, right? So time to reach the maximum height was like 0,6, so we can say that part is somewhere here. Yeah, so now once you have that, now you can just construct your straight line. Make sure it's straight, yeah, just like that, right? Always make sure you use a rule. So now remember, you make sure you stop where you put the dot, like that. So you should have something like that, right? And then you put a dotted line just to for just to close it down like that, right? Yeah. So now this is how we draw it, right? So now you're gonna indicate your V initial was 5,88, and here you're gonna say negative 15,18, right? And this time here was what? 0,6, right? So this is time is in seconds, right? Yeah, and then you stop right there, right? So I believe this is how I hope you guys understand, and this is how we answer vertical projectile motions, and this is how we interpret position time graph, right? So thank you guys for attending, and I'll catch you guys next time. Take care.